Okay, linear programming, example 2. You can press pause and copy this down if you haven't already, but this is the process we use for linear programming problems. Let's dive in. A company is experimenting with a new dry cement mix. In order for the cement to set properly, the company has determined that the mix must contain at least 90 ounces of sand, 60 ounces of dirt, 100 ounces of filler, and 50 ounces of dry antifreeze per bag. The company has available 2 products which they want to mix together to make a new product. Product 1 has 25 ounces of sand, 10 ounces of dirt, 35 ounces of filler, 5 ounces of dry antifreeze, and costs $1.20 per ounce. Product 2 has 10 ounces of sand, 10 ounces of dirt, 20 ounces of filler, and 25 ounces of dry antifreeze and costs $1.60 per ounce. Determine how many ounces of each product the company should use to keep the cost of the new cement to a minimum. Okay, so this is a little different than the other problem because we're asking to find the cost, keeping the cost to a minimum. All right, your variables. Determine how many ounces of each product the company should keep. So they have product 1 and they have product 2. So those are going to be your variables. But let's go ahead and set up a table here. You got your product 1. Let's do that in a color that we can all see. Product 1, product 2. Okay, product 1, what do we have in all these products? We have sand, we have dirt, we have filler, and we have antifreeze. Okay, product 1, this is, they must have at least. These are kind of, this is not what I'm going to use here because this is not referring to product 1 or product 2. This is how much the company has to use per the amount of products they have. So we skip down here to product 1 has 25 ounces of sand, it has 10 ounces of dirt, 35 ounces of filler, and 5 ounces of antifreeze. Product 2 has 10 ounces of sand, 10 ounces of dirt, 20 ounces of filler, and 25 ounces of antifreeze. The total amount that they have to use here, and I know on the other table, I think my total was over here to the side. Well, now my total is underneath. They have how much sand? 90. This is going to use this number right here. They have 90. That's supposed to be a 0. 60 ounces of dirt. Oh my gosh, I can't write. 100 ounces of filler, and 50 ounces of dry antifreeze. All right. My variables, let's just reiterate. The last time I had my variables, I think along the top, product 1 we're going to call X, product 2 we're going to call Y. Okay, and it'll still set up just fine if we do it this way. Okay, the next step then, after I get my variables decided, is I'm going to write my inequalities. I'm going to use my chart here to do that. So I'm going to write a sand inequality. So I have 25X plus 10Y. Now, here's the thing they've got. They must contain at least 90 ounces of sand. Okay, if I have at least 90 ounces of sand, then I'm going to write greater than or equal to. So that's kind of an important word, where I think the other one, you only had so much product, but here, inside the product that you're making, like in the recipe, you have to have at least 90 ounces of the sand. Dirt, 10X plus 10Y is greater than or equal to 60. Filler, 35X plus 20Y is greater than or equal to 100 because you have to have at least 100 ounces in there. And antifreeze would be 5X plus 25Y is greater than or equal to 50. Okay? So I've got my inequality set up. Now I need to graph each inequality. And once again, I think I will show you probably every single problem, 0, blank, blank, 0, the X and Y intercepts. Now, in your world, if you want to switch that into slope intercept form, I am not going to fight you on that, but I just want you to know how it's going to set up for me. So if I do my X and Y intercepts, I got 0, 9, and 3.60. Okay? And once again, you put 0 in for X, so 10 times 9 gives you the 90. All right, you put 0 in for y, 25 times 3.6 gives you 90. Okay, on the next one I put 0 in for x, I get 6. If I put 0 in for y, I get 6. So I got 0, 6, 6, 0. On the next one, if I put 0 in for x, I get 5. And if I put 0 in for y, 35 times what gives you 100 is 2.86. Maybe I should have waited just a little bit before I wrote out that. 2.86. 0. All right? And the last one, if I put 0 in for x, then I have 2 for my y value. And if I put 0 in for my y value, then I get 10 for my x value. So 10, 0. All right, I'm going to graph the first one. And once again, if you don't have colors, feel free to use different symbols. So like here, I'm going to use a star, 0, 9. All right, 3.6 is right about here, 0. So I'll put there, and I make my line. Okay, and I want this red. I think this will do it here. Oops, red. Nope. Try again. Okay, before I forget, now I'm going to shade. I have to shade, and here's the interesting thing. Because it says greater than or equal to 90, if I test 0, 0, is 0 greater than or equal to 90? No. So this point right here, 0, 0 is false. So I have to shade everything on this other side. So let me do highlighter here. Let me go with red just to keep ourselves. Why did it not go red? Go red for me there. All right. That's good enough, right? Okay, we get the idea. All right, keep track as you're going because it does get a little, it can get a little challenging there. All right, now I'm going to go ahead and let's do a blue for the next line. All right. Oh, come on, blue. Okay, once again, I have 0, 6, 6, 0. So I'm going to use a different 0, 6 is right here. I'm going to use a square, and 6, 0 is right here. And I'm going to, once again, use the line through those 2 points. See if I get it to all match up here all nice. Oh, look at that. Undo. Because I really want this to be in blue. Okay. And what do? We test 0, 0. 0 plus 0 is greater than or equal to 60. Not the case, so I have to shade everything on the other side, not the 0, 0 side. So here we go. Oh, it did not do that to me. Am I still about where I want it to be? Okay, that looks better. All right, what is going on? I feel like it's like delayed. Somehow my board is delaying in my... Okay, so I shade everything on this side of the blue. Oh, you know what I kind of forgot to talk about? Once again, the X and Y axis. Are we going to make a negative product, a negative amount of product 1 or a negative amount of product 2? Okay, because we're not going to do that, we are limited to the first quadrant. Our X and Y axis is going to keep us inside there. I know I shaded down, but we're going to have to keep that in mind as we work through. Oh, let's go crazy with a little pink here. All right, so my next one, I have 0, 5. I'm just going to put a dot this time. And then I have another point at 2.860. 2.86 is right around here, and I need to make a line through that, just like you will. Line, 2.86. We're doing it in this color. Here we go. Okay. Yep, it's kind of slow. Okay, and I'm going to shade. And once again, I test a point. 0, 0 is not greater than or equal to 0. So I'm going to test, or I already tested, and that one is not going to be less than. It's going to be over here on this side. So I'm shading everything over here. Okay. All right, and then I have one last graph to deal with. let's go purple. All right, 5x plus 25y, 0, 2. So this time I think I will put an x, and then I have 10, 0. And I'm going to put an x there, and I need to make a line that's going to represent the boundary of that inequality, and these are solid lines, thank goodness. See if I can make it straight and effective. Oh, guess what I did? You're like, Mrs. Talley, does it really matter what color? And I'm getting all particular about it, so yeah, I guess it does matter. There's my purple. I'll try again. Here it is. All right, and I would test 0, 0, and 0, 0 would be false, so I have to shade everything on the other side, and let's see, do I need purple again, and everything up above here. Okay, so now where is that? What's that word again? Feasible region. We're looking for the feasible region. Okay, let me shade or kind of highlight the boundary of this. So it starts here, and it moves its way down here, so I think this was the red line, and then we run into the blue line, and I keep following over here, and now we have another intersection or a vertex with the purple line, and then we come over here, and then we end, okay, my line is off, but it does, come on, I feel like my Promethean board is tired today. All right, it does end right here where it's supposed to be 0, 10. So, what's the next step? The next step, and I'm not going to shade any much more than that because we're going to get too confused. The next step is to label my vertices. So I have a vertex right here. We're going to put that one down first. So I have one at 10, 0. I have another vertex, well, let's write this one down. I have another one at 0, 9. But I have to figure out this vertex, and I have to figure out this vertex. Here is the kind of not fun part about this. You have to make sure you're using the right equations, or excuse me, inequalities, to make this work. Okay, so I need to know where the red line runs into the blue line. So I need to do the red line with the blue line. So in other words, when does 25x plus 10y equal to 90? The same as 10x plus 10y equal to 60. Well, the cool thing is I can eliminate the y's really easily by just switching my signs. Okay, these are going to cancel out. It's the whole idea of elimination. 2x minus 10x is negative 8x, and 90 minus 60 is 30. So if I solve that, I get x is equal to, let's see, 3 and 3/4. Why do I have a negative? I'm not liking it. All of a sudden, I'm not liking negative 3 and 3/4. 25, oh, 25x, 10y. So 25 minus 10 is 15. My bad. Let me try that again. So I actually have 15x equals 30, and I like that a lot because now I get a nice little number like x equals 2. And then I go back and I try it out, and I'm going to go back here, I guess. 25 times 2 plus 10y equals 90. So I have 50 plus 10y equals 90. 10y is equal to 40. That makes y equal to 4. So my intersection should be occurring right around 2, 4. Let's kind of double check. 2, 4. Seems like it's pretty good in the vicinity. I like it. I'm going to write 2, 4. Okay, the next vertex of the feasible region is where the purple line crosses the blue line. Purple crosses the blue. So now I've got to figure out this and this one. Where's the intersection of those 2 points? All right, I'm going to kind of scroll down just a little further here. Or am I? I am. Okay, so I've got 10x and 10y. Goodness, Lord. 10x plus 10y is equal to 60. And my other one is 5x plus 25y is equal to 50. And I'm going to solve this system. Well, I want to get rid of the, I think I'll go with the x's. So I'm going to multiply, Multiply this equation. Uh-oh. No. Oh my, did it just erase? Sometimes when I get the spinning wheel, the whole thing shuts down. I'm going to do one little thing here and see if it works. Oh no. Okay. Good thing I wrote that number down because I'm going to just pick up here. I had 10x plus 10y is equal to 60. And then I think I also had to do, oh, I hope I wrote that number down. Oh, it doesn't matter. I can figure it out anyway. And then I had 5x plus 25y is equal to 50. And I was just in the process of multiplying this whole thing times -2. That way I would have 10x plus 10y equals 60. I'm rewriting the top one, taking the bottom one times -2. And I get a -50y, and I get a -100. This is gone. This becomes -40y, and this becomes -40. So my y value is 1. Now I go back, I think I'm going to go back to this one, and I have 10x plus 10y, but my y value is 1. Substitute in, 10x plus 10 equals 60. 10x equals 50 because I subtract 10 from both sides, and now x is equal to 5. So I have an intersection at 5, 1. I almost wrote 1, 5. Can you see why I might have made a mistake? Almost made a mistake there. So 5, 1. Uh-oh. All of my points are gone. Okay, let me put it back up there. 5, 1. Hold on. I think I could find the other one was 2, 4. And then I had 0, 9. And then I had 10, 0. Woo! I was nervous when I saw that spinning wheel. Usually my computer, my Promethean board completely shuts down. Okay, now the next thing is we need to write a max profit or a minimum cost statement. And here's the cool thing. Let's see if I can find it all. Product 1 is $1.20 per ounce. Product 2 costs $1.60 per ounce. So you're going to have your cost statement, $1.20 per ounce, and that's talking about the X values. And then we have $1.60 per ounce, and that's talking about our Y values. That's product 2. So now I get to put in 10 for X. So 10 times $1.20 is 12. That's my cost. All right, 0, 9, I put 9 in for Y. So whatever, 9 times $1.60, let me grab my calculator quick here. 9 times $1.60 is $14.40. So this is $12. That's supposed to be a dollar sign. I think I made that worse. If you put in 2 for X, that's $2.40. And if I put in 4 for $1.60, I think that's $6.40. So that's $8.80. All right, and if I put a 5 in for X, I believe that's $6. Plus, I put a 1 in for Y, that's $1.60. So I think that's $7.60. Okay, now the question is, what should they do? How many ounces of each product should the company use to keep the cost to a minimum? So which one here is your minimum cost? Well, of all these, it's $7.60. All right, so you would want to make 5, is it bags? I think it's bags. 5 bags of product 1 for every one bag of product 2. So 5 bags of product 1 would be your answer, and then 1 bag of product 2. Yippee-yi-ki-yay. Now I'm wondering, on the first example, did I ever answer the question? I'm pretty sure I did. All right, well that was fun. And that ends number 2.